Today, we're going to find the power absorbed by a certain resistance R1 and the voltage VAB with a switch open and closed. So let's draw our circuit as we always do. We're going to have a voltage source, a resistance, and this one is going to be our point A, and we're going to have another resistance here and another resistance here, and then a diode polarized this way in this direction, like so. And then down here we're gonna have a other resistance here, and then everything is gonna be connected here. Now here we're gonna have another resistance, but on this side I'm gonna call this one B, but on this side where there is A, we're gonna have a switch. And the switch is like this. I'm gonna call this R, V, R, 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 and R1. The problem this time is saying for the circuit on the left, we know that V is totally equal to 12 volt, R is equal to 2 ohms, R1 is equal to 1 ohm. Find the power absorbed by the resistance R1 and the voltage VAB with the switch, which I'm gonna call D, which stands for time. I could actually call this S, which stands for switch, is the same. So the switch T open and closed. So this is our circuit. Now, when the switch is closed, so when a switch like so, okay, now when a switch is closed, like when a switch is closed, okay, we're actually going to add a PR1, which is actually 0. And the voltage is VAB is actually 0, because if I'm gonna close this, basically gonna have a short circuit. So with the switch closed, I'm gonna have a short circuit. So PR1 will be 0 and VAB will be 0 as well. Because, if you have a voltage and the switch is actually closed, like so, the current it's just gonna flow this way. It's just gonna have a short circuit. It's not gonna flow here on here on here. So between A and B, there is nothing going to be here. There's nothing going to flow through B. So this question is easily answered by saying the power is 0. So there is no going to be anything, any current flowing through the resistor 1, R1, and the voltage across VAB, so here, going all the way down here to B, there's nothing going to be to B. There is nothing going to go to B. So the voltage is going to be 0 as well. Because, nature is not, the current is not actually stupid. It's just going to go through the easiest path. So is it going to go through those resistances and the diode, or is it just gonna flow through the short circuit? So to this cable with 0 resistance. Of course, it's gonna flow this way. So you can all those two meshes. Well, this mesh and this mesh, and it's actually gonna flow through this. So when the switch is closed, PR1 is 0 and VAB is 0. So that was easy. That was quick. Now, with T open instead, I'm gonna consider this. With T open, I'm gonna consider this circuit. So I'm just gonna consider this circuit here. So my power supply, plus minus V, R, my point A with nothing attached because T is open, so there's nothing attached, R, and then all the way down here with R. Then there is nothing gonna be here because the diode is polarized in this direction, so is going to allow the current flow in this direction, but current is actually flowing in this direction. So I'm just gonna short circuit it like so, just to remember that there was a diode once, but it's not gonna matter. And at the bottom, I'm gonna have a resistance going all the way to here. Now here, still gonna have these resistance that I had before. This is still gonna be my point B, and this is still gonna be my point A, but I'm not gonna have anything attached here. So this is R, this is R, this is R, and this is R1. So I'm just gonna consider and work on this circuit here. Now, the diode, as I said, is polarized in this direction. So as I said, I just draw it as a short circuit. Now, when and I'm gonna define these as I. Well, I'm gonna define also the current here as I. Okay, so the current flowing there is gonna be called I. Now, if we look at the generator, we would have, well, how can I, well, I'm just gonna do this as my action plan. I'm just gonna find the R total, which is gonna be R in parallel with R1 plus 3R. So R total is, well, R, which is, I didn't write it, dang. I should really write that. I always say to do it, but that I'm going to do it, but I never do it. 12 volt, R is 2 ohm, 2 ohm, 2 ohm, 2 ohm, and 1 ohm. So R, so 2 in parallel with 1 plus 3 times 2. So R total is the product over the sum, so 2 times 1 over 2 plus 1 plus 3 times 2, which is 6. So R total is 2 times 1 is 2, 2 plus 1 is 3, plus 6. So our total is 3, 2, plus 12. No, 18, sorry. 6, 12, 18. Yeah, I was almost going to make a mistake on something trivial. So 18 plus 2 is actually 20 over 3. So 20 over 3 is, oh well, 20 over 3 is 6.66. But is it correct? I think I made some mistake. I'm sorry. 2 over 2 times 1 plus 6. Actually, 6.66. Did I make? Yeah, this is correct. This is actually 2.6.6. Yeah, this is correct. I don't know why I was actually double checking because, but well, yeah, 20 over 3 is 76.66. Okay, so our total is 6.66 ohm. Now we can actually find I, which is the current. So by definition, by Ohm's first law, VIR, so remember the triangle, I'm always gonna see it, I is V over R. So we have V over R. R what? Well, R total in this case, because we are gonna find I total. So I total is 12, which is the voltage, over R total, which we have just found is 6.66. So I is 12 over 6.66 is 1.8 amps. Now I1 which is the one we are actually interested in, because we gotta find the problem is actually asking us the power absorbed by resistance R1, which we're gonna call PR1. So I1, we are actually interested in the current flowing through this single resistance. So I1 is actually gonna be a subset of I. So now that we have found I, and say okay, so I1 is I over R over I times R over R plus R1. So I1 is going to be, well, I is 1.8 amps, R is 2 ohm, R is 2 ohms, and R1 is 1 ohm. So I1 is 1.8, well, let me just, yeah. 1.8 times 2 is 3.6, over 2 plus 1 is 3. So 3.6 over 3 is 1.2 amps. So we have 1.2 amps. We're getting closer. We have the current flowing through here. So now we can find the power. So the power absorbed by the resistance R1, which we're going to call PR1, is just going to be R1. Well, if you know the Ohm's third law states that the power is I squared times R. So PR1 is just going to be I1 squared times R1, of course. So, yeah, PR1 is going to be, well, let's just plug numbers in here. We have 1.2 squared. Oh, no, yeah, 1.2 squared times R1, which was 1 ohm. So PR1 is 1.2 squared, which is 1.44 times 1. So PR1 is just 1.44 watts. Now, the problem, we are almost there because we have found the power absorbed by the resistance R1. Now, the second thing that the problem is asking us to find is the voltage VAB. So the voltage VAB, so the voltage across A and the points A and B, which we're going to call VAB, is actually going to be R times I plus R times I minus I1. So we would have R times I plus R times I minus I1. So VAB is going to be R, which is 2 ohm, times I, which is 1.8 ampere, plus R, which is 2 ohms, times I, which is 1.8 ampere, minus I1, which is 1.2 ampere. 1.2 ampere. So VAB is, well, is 2.108, which is 3.6 plus 2 times 1.8 minus 1.2 is 0.6. So VAB is 3.6 plus 2 times 0.C is actually 1.2. So VAB is 4.8 volts. And we have found what the problem was asking us to find. So the power absorbed by the resistance R1 and VAB, which is the voltage VAB across those 2 points.